So that is there. So basically, we'll cover binomial distribution, we'll cover exponential distribution, we'll cover Poisson distribution, and we'll cover the normal distribution. Uh, so the flow is going to be as follows, right? So I am first going to, for each of these, I'm first going to tell you how the distribution looks like, right? So um, here there is a distribution function that is involved in each of these distributions. Now, for the discrete probability distributions, it is called a distribution function. Otherwise, it is called a density function for the continuous probability distribution. Okay. So once we identify and get used to, like get acquainted with the density and the distribution functions, what we'll do is that we will look at the formula for the mean and the variance, right? So I think we are not going to go into the derivation of those because they are a little bit more time consuming and tricky and maybe not that important from your examination point of view. However, what we'll do is we will solve some problems, right? And that will be it, solve problems. Okay. So let's start with the binomial distribution. A little bit of binomial distribution has already been told to you previously. So we'll start with the binomial distribution. Binomial distribution. Okay. So the word binomial comes into play because there are two kind of variables, or two identities, two entities that are involved in this distribution. Uh, so in probability, those entities are the possibilities. So there are two possibilities here, two possibilities, two possibilities. And these possibilities are, one of the possibility is a success and another is a failure, right? Or a few examples can be added here. So let's say the heads or a tails when a coin is tossed, right? And it can also be, let's say, when you roll a die, right? Getting a 6 or not getting a 6, right? So this is also an example of success and failure. Or maybe not getting a 6 is success and getting a 6 is a failure. Even heads or tails, right? Heads is a success, tails is a failure, or the other way around, tails is success, heads is failure. And it all depends on the question, right? In the question, whatever it is being asked, from there you have to identify what is the success and failure. We'll solve a problem and we'll identify how to find out that. So both of these possibilities are associated with probabilities, right? So there is a probability of success, and there is a probability of failure, of failure. Okay. So we represent the success probability by P and the failure probability by Q. Now, if you remember, we had multiple times mentioned about a particular theorem in probability, right? So the theorem goes as follows: the sum of all probabilities probabilities is 1, right? So from here, since this is true, what we can write is that P plus Q is equal to 1, or we can also write the Q in terms of P, 1 minus P, right? So this is one of the most important things that you need to remember, right? P plus Q is equal to 1 and Q is equal to 1 minus P, because sometimes in the question the probability of the failure is given, sometimes in the question the probability of the success is given. If one of them is given, the other one can be found out through this way. Okay. Now, what happens is that okay, let's put it here. Okay, so what happens is there is a story. The scenario is as follows. The scenario is as follows. What happens is we are conducting an experiment, right? We always conduct experiments in order to find out probabilities, right? So whatever is given in the question is basically an experiment. So we are conducting an experiment in which there are there are in which there are, let's say, n number of n trials. Okay, there are n trials. And what does a trial mean? A trial means that we are doing an activity. It's an activity with two outcomes, with two possible possible outcomes. One of these outcomes is a success, and the other outcome is the failure, right? This is a binomial distribution. So there are two possibilities, right? So we had seen this before. There are two possibilities. There is a success, there is a failure, and when we are conducting an experiment, we are having this activity done n number of times. Now n is an integer, right? N can be 1, it can be 2, and so on. Now the question is, given this scenario that we are conducting an experiment in which there are n trials, the question of probability is, what is the probability of x number of successes? So how many times x successes occur, right? So that is the question we are going to ask, and that is the question we are going to answer using the binomial distribution. For example, just for getting you on board with this idea, what happens is that let us toss a coin, uh, let's say 6 times, right? Then find the probability of two heads, right? That is the scenario that we are talking about, right? So what are the possibilities here? The possibilities is that there can be one head, there can be two heads. These are all the possibilities. There can be five heads. It might be possible that every time I'm tossing the coin, all these 6 times to be specific, I am getting tails 6 times, or maybe I got 6 heads. But what we want to find out is what is the probability of getting two heads, right? Now, when we are talking about the formula for this particular probability distribution, the probability of x successes from n trials is given as follows. So the probability, so the probability of x successes from n trials n trials. So this is given as follows. We write p, and then there is a capital X. This capital X represents, let me tell you, the random variable. This is the random variable. Okay, this is a random variable. What is a random variable? A random variable is a variable that we use in probability. It has got some properties. Let's not get into them. But anyhow, the value of x is equal to small x. Small x is the number of successes. So the random variable is counting how many successes are happening. Correct? So this value will be n choose x, right? This is the combinatorics expression, and we will write p raised to the power x. So what is p? P is the probability of success, right? We had seen that above here. Probability of success is p. On the top of your screen you can see that probability of success is p. So there are x successes, right? So since there are x successes, we raise p to the power x, and since the rest of them are failures, we write q to the power n minus x, right? So if we do a little bit analysis of this formula, we can do it in this way. So p to the power x, right? So this means there are x successes, x times successes, and q to the power n minus x would mean that the rest of them, rest are failures, right? And the rest, how many rests are there? N minus xy, the total is n, right? So this is the formula that we are going to use. And also, let me also write down what ncx mean, right? Ncx means the number of ways or combinations, right? This is the number of combinations of choosing x items from n items. So there are total of n possibilities, right? There can be there are n possibilities over here. There are n possibilities here. N possibilities here. What are the possibilities? What are the possibilities? Right? There can be success. There can be n different possible scenarios over here. Actually, it is n plus one. Pardon me. There are n plus one possibilities. So what are the possibilities here? One possibility is x is equal to 0. There is no success. Another possibility is x equal to 1, x equal to 2. These are all possibilities. All the way to x equals n minus 1. There can be n minus 1 possibilities, right? And there can be the value of x can be equal to n, which means that there can be n the value of there can be n successes. So there are n plus 1 possibilities of the number of successes, right? So so we use this ncx to determine the number of ways of choosing x items. So the x can be 0 items from n items, 1 items from n items, and so on. And there is a beautiful formula for this. So ncx is equal to n factorial divided by x factorial multiplied by n minus x factorial. Correct? So this is the formula that we will be using in in our calculations, right? Okay. Now here you might be little worried about how to deal with this factorial symbol, right? What is n factorial? What is x factorial? There is a factorial symbol over here. On the keyboard, on the computer keyboard, you can get this factorial symbol by pressing the shift and the button corresponding to 1, right? So the factorial means the following. So let's say we have got a number, say 3, and the 3 factorial would be 3 multiplied by 2 multiplied by all the way to 1, right? So this product is called the 3 factorial, right? So this value is going to be 6. Again, for example, if you look at 6 factorial, 6 factorial will be 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which you might get as 720, right? So what we do is that we calculate the n factorial, divide that by x factorial. We'll calculate n minus x. Remember, n, x, all of these are numbers. Excuse me. And we make this calculation over here. Okay. Now let's try to solve this problem. Toss a coin 6 times and find the probability of 2 heads, right? So let's solve this problem. Toss a coin 6 times and find the probability of 2 heads. Okay. Now from the question, you see that the question is asking us to find the probability of heads, right? we want to find out the probability of heads. So heads, so the heads is going to be our success. Okay, so in your mind, whenever you are looking at the question and the question is asking you something, that something is supposed to be the success. Okay, cool. Now that we know what is the success, what how we define the success, let's get into it and let's try to solve the problem. Okay, now um, what happens here is we will first identify what is n. N is 6 because there are 6 trials, right? So each trial is tossing a coin. Again, trial, I missed mentioning it. So toss a coin, toss a coin is called the trial. So how many trials are happening? There are 6 trials happening. So n is equal to 6 and number of success x is equal to 2. Now we have to find out the probability of success, correct? So the probability of success is given by P. And in the question, if nothing, if no other extra information is given about, the coin, and it is said that you just toss a coin, we will assume that the probability is half, right? So equal probability for heads and tails. So the probability of success P is half. So Q would be 1 minus P, as you had seen before. So that is 1 minus half, which is equal to half. Got it? Now we are going to use the formula over here, right? So the formula, what does the formula say? The formula says that the probability of x successes, on the top of your screen you can see the probability of x successes from n trials is called Px equal to x, which is equal to ncx p power x q to the power n minus x. Okay, so here the probability of x equals 2 will be given by, the formula is ncx, correct? Ncx, that's the formula. Ncx p power x and q power n minus x. Okay, so let me see if I can remember it correctly. So ncx p power x q to the power n minus x. Okay, cool, seems good. So n is equal to 6, c 2, p is half, half to the power x, so this x is 2, and q is also half, half to the power n is 6 minus x is equal to 2, right? So now here what we do is we will find out what 6c2 is, and then half square and half raised to the power 4. Now 6 factorial is the numerator because ncx is given by n factorial by x factorial. X factorial is 2 factorial and n minus x factorial. So 6 minus 2 factorial. Then we have got a half to the power of 2 and another half to the power of 4, right? So this is the probability. We will calculate this value and we will write down what the correct answer is, what the probability of two heads is. So, but before that, let's go through the solution once more till this. The question asks to find the probability of two heads when the coin is tossed 6 times. So the activity of tossing the coin is called the trial. I've written that with the orange pen. And the heads, the possible outcome heads is called the success. We need to find out the probability of two successes. So x is equal to 2. Number of trials is 6 because the coin is tossed 6 times. So n is equal to 6. Since no other information is given about the coin, right, we'll assume that the coin is a fair coin, which means the probability of heads is equal to the probability of tails, and which is, and both of them are equal to half, right? So the value of P is going to be half, the value of Q is also going to be half. Of course, I've used a formula, a small formula over here, which is pretty easy to understand because the sum of all probability should be equal to 1. So Q is equal to half, P is equal to half. n is equal to 6 and x equal to 2, that is these are the values that we substitute in the distribution function, right? And we end up with a pretty good set of numbers here. Okay, so 6 factorial would be written as 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied 2 multiplied 1 divided by 2 factorial is again 2 multiplied by 1 multiplied by, then the next bracket here says it is 6 minus 2, right? So 6 minus 2 is 4. So 4 factorial. So 4 factorial is 4 multiplied 3 multiplied 2 multiplied 1 multiplied by half square. Half square is half multiplied by half multiplied by, oops, I'm running out of space. Half to the power 4. So that is half multiply half multiplied by half. Okay. So what to do next? We shall do some cancellations, correct? So I'll use a yellow pen for doing that. Let's see. Okay, not the yellow pen, maybe the red one. Red one is better. Yeah. Okay, so 1 get cancelled. Doesn't matter. 2 get cancelled. 3 get cancelled. 4 get cancelled. And the 2 here get cancelled with the 6 here. We get a 3 here. Right? So in the numerator, we have got 3 multiplied by 5. And in the denominator, we have got 2 multiplied 2 multiplied 2 multiplied 2 multiplied 2 multiplied 2 6 times, right? So 1, 2, 3, 4, 5, 6. And in the numerator, we have got 3 multiplied 5 and rest of them are 1. So we don't need to be bothered about them. So this is 15 divided by 64. So we can finally write down the answer that therefore the probability of two heads when a coin assumed to be a fair coin is tossed 6 times is equal to 15 by 64, and that's the answer. Now, there are a lot of variations to this question, by the way, right? And all those variations can also be applied. So, for example, there might be another question, a sub question attached to this, uh, which you can do it as a homework. It says find the probability of x is equal to 5. Find the probability that x is greater than equal to 4, right? Find the probability that uh, x lies between 2. It's not strict over here, whereas it's strict here, right? So in the first case, you just put the formula, right? Put the formula for x equals 5. Then in the second formula, you'll have to put x equals 4, x equals 5, x equals 6, right? And then you have to add them. And the last one, x is equal to 3, x is equal to 4, and x equals 5, and you have to add them. So you have to put this, substitute x equal to 4, 5, 6 in the second problem, and 2, 3, 4, 5 in the third problem into the formula separately, like 3 times you have to do it. And whatever answer you get at the end of each calculation, at the end you come and add them up. Now there is a little tricky question over here that I would want to uh, share with you, that is probability of x greater than 5, right? Now in order to find this, no, sorry, not greater than 5, let's say less than equal to 5, right? So here we have got x equals 0, x equals 1, x equals 2, x equals 3, x equals 4, x equals 5. So many you have to find out and add. But we won't do that, right? This is not a good and smart way of doing the problem. So what we'll do instead here for this problem is as follows, right? So what are the possible values of x? The value of x can be 0, 1, 2, 3, 4, 5, 6, right? So these are the possible values of x. So you see that we want the summation from 1 to 5, right? So smartly we can write it as follows: p of x less than equal to 5 plus p of x equals to 6 is equal to 1. So probability of x less than equal to 5 is equal to 1 minus probability of x equals to 6. And then we will find out this particular value by substituting x equal to 6 in the formula. And we will get the answer in a smarter way. So instead of doing like 6 different calculations, we just do one calculation and one subtraction, and that is going to give us the answer. Okay, so much so about the binomial distribution. So as a short revision of what we did just now is that we are considering just two possibilities. There is a success and there is a failure, and we are having a finite number of trials over here, right? So we are conducting an experiment. At the bottom of the screen you can see, right, in which there are n trials, and these trials, what do you mean by a trial? Again, trial is an activity which has got two possible outcomes. One of the outcomes is success, another outcome is the failure. The example that we have taken up is tossing a coin, in which we are trying to find out the number of heads, the probability of two heads actually, right? So the heads, that's what the question asks for, is the success, and the other possibility is the failure. So we also have a probability of the success, we have the probability of failure, and that gives us, the summation of those give us 1. So basically, we are conducting an experiment with n trials, and we are interested in knowing the probability of x number of successes, right? And the probability of x successes from n trials is given as ncx, right? ncx p to the power x, right? And q to the power n minus x. I have just put that in a yellow box over there in the bottom of your screen, right? So that is the formula for finding out the binomial distribution. This is the binomial distribution function. And a little about this function: there are x successes, and that's why we are writing p to the power x. There are q failures, there are n minus x, right? If there are x successes, the rest of them are failures. The rest is n minus x. So q is raised to the power of n minus x. These are all multiplied. As you can notice that p is multiplied with itself x times, and that product is multiplied with the product of q n minus x times. So there are n, uh, like for each of the trial there is one probability attached, right? N times it is happening, right? So x times p is happening, n minus x times q is happening. So we are multiplying all of these together because all of them are independent. Once you toss a coin, the result does not affect the next coin toss, or like two coin tosses are pretty like detached from each other, right? So one result does not affect the other. They are independent events. They are called in probability as independent events. So having said that, we also discovered that we are going to use the combinatorics formula over here, that is ncx, which is equal to n factorial divided by x factorial multiplied by n minus x factorial. Okay, so that is that about the binomial distribution. This is the binomial distribution. Next, we will move on to the exponential distribution, right? We'll move on to the exponential distribution. Oops, my bad. Okay, exponential distribution. exponential, exponential distribution. All right. So since this is a live class, I have not been able to talk to you much about the uh, the topics. So can I, in the meantime, get a few thumbs ups in the chat somewhere? Okay, that's good. That's good. Hmm.
ಚಾಟ್ ಮಾಡ್ಬೇಕು.
If you have any doubts here, maybe you can come up and ask your doubt. It's pretty simple, so I don't think there are any doubts over here. Okay, I can see a few raised hands. Uh, are you raising your hand because you have any doubt? Do you have any doubts? Swatin Raj, Pratiksha, Nikhil. Okay, Nikhil has put down his hands. Amulya, you have any doubt? Maybe you have, maybe you are confused with the thumbs up and the raise hand button. Okay, okay, hold on. So before going into exponential distribution, the exponential distribution. Okay, by the way, thanks for all the thumbs ups, right? Before going into the exponential distribution, my bad, exponential distribution is a, what to say, it's a continuous distribution. Before going there, I had also mentioned that I'm going to tell you about the mean and variance, right? The mean and variance. So the mean and variance, as you remember, there is a formula for the mean and variance, right? Uh, the mean is summation of xpx, and the formula for the variance is summation of x square px minus mu square, right? So we will not go into all of those derivations over here, but the mean here is n multiplied by p, and the variance is n multiplied by p multiplied by q. Also, if you are not that, if you do not want to find out the value of q, um, the value of p will give you the value of q as 1 minus, oops, 1 minus p. Mm, okay, so this is going to be the formula. This is a very important formula, right? So in our problem little while back, right? So if we want to, like in the dot 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 continued from our example, from our example, uh, like our n, what was the value of n there? The value of n was 6 and the value of p was half, right? So the mean, again it is represented by mu, is equal to np. Np will give 6 multiplied by half, which is equal to 3. And the variance sigma square is np multiplied 1 minus p. So n is 6 multiplied by half multiplied by 1 minus 1 half. So that should give us, let me scroll it a little bit. Okay, yeah. So 6 multiplied by half, that will be 3 divided by 2. Oops, 3 divided by 2, right? So the mean is 3 and the variance is 3 by 2. So that's another important thing that we should remember. Okay. Yes, so in the first slide itself, I had made a small mistake there. Exponential is a continuous random variable, whereas Poisson is a discrete random variable, Poisson and exponential. So there is, like things get a little confusing here, because let me tell you, in the Poisson as well, we will find something like e to the powers of something. So like it's quite common that people make a mistake there. Excuse me for making that mistake. Anywho, let's get into the next probability distribution. Uh, Again, we'll follow the same rule. We'll first find out the explore what this Poisson distribution is, and then we will look into uh, you know like uh, we will look at what are the look into a problem maybe, and then we'll identify the mean and variance, right? So Poisson distribution, Poisson distribution, Poisson distribution. So again, this distribution is for example, you are operating a telephone at a telephone exchange, right? So nowadays there is this IVR, correct? So uh, human beings have been replaced by some algorithms, some bots, not necessarily AI powered, but if your, let's say the phone network is not working, or maybe your computer button is not working, or some algorithm is not working, you call up the helpline number, and the helpline number resolves your. So in order to manage the resources at the back end of the helpline number, they need to know, the company, the organization needs to know uh, how many calls are they expecting to receive, let's say in the next 1 hour, or in the next 8 hours, right? So usually there are like you know workers or employees have a shift of 8 hours or 7 hours. So in that duration of 7 to 8 hours, how many calls is that particular employee uh, going to get, right? Going to receive on the helpline number. So this is one of the places where we use the Poisson distribution, right? So again here, um, so um, yeah, so here as well we deal with two possibilities, right? So that there is an activity uh, which has got two possibilities, and as you have seen in the normal in the binomial distribution, the possibilities are success and failure, right? Again, if you're getting a call, it is a success. If you're not getting a call, it is a failure, right? Okay. Again, here as well, we assume that that uh, a- an event, an activity, a trial cannot happen one after the other, right? Uh, and and also another assumption that we make here is that the number of trials is infinite. We are not going to, so this means that we do not have a value of n. We are not going to fix, saying that okay, you know what, this is the value of n. We're not going to fix that value of n. So there are two possibilities, a possibility of the success and a possibility of the failure, right? So okay, now if we try to write down a formula here, um, so again, the success over here has got a probability attached to it, right? So what we say is that the mean, or the expectation of a success is equal to lambda. So this is basically the information that you should be able to fish out from the question or the scenario that you're trying to model. So you have to find out what is the value of lambda, right? What is the expected success rate? Okay. Now once you get this, right? Um, so so the question here is a little different, right? The question here is a little different. Let's write down the question, correct? So the question here is the scenario. Let's write down the write the word, use the word scenario here. What is the scenario? The scenario is as follows. We are having a trial. A trial is repeated infinite times, or indefinite, for indefinite indefinite time, right? We are not bothered about the number of trials. We do not have a value of n, right? The number of trials, as we had mentioned previously, is infinite. So we do not have a value of n. And the question is, again, each trial has got its success and failure, right? So the question is how many, how many, how many successes? Okay, so this is this is the this is basically the question that we are trying to answer. Let's say that there is a trial that is repeated for infinite number of times indefinitely. uh, what is the probability of this many successes, right? So if we say that x is the number of success, so we are going to ask what is the, oops, let me write it down properly, what is the probability of x number of successes. So for example, again, let's take a scenario over here, right? So let's say, someone is sitting in a call center. Usually the call center question is like really relevant over here, right? That example is very frequently used in this kind of a scenario. So in this call center, in this call center, there are phone calls coming to uh, there are phone calls coming to a particular um, employee, right? So let's say that a call center, oops, the call center receives, uh, let's say that the call center receives, oops, my bad, RECEI, call center receives 2 calls per minute. Okay, that is the, that's the average, that's the expected value. Okay, so this is the expected value. Let's write it down with the orange pen, right? So this is the expected value. We are expecting, the expected rate is 2 calls per minute, and we need to find the probability, of uh, let's say 0 calls in a particular minute, right? So this is the number of success. The number of success is given by x, correct? So this is the value of x, success, 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 right? So what does it mean? It means that maybe there is, the call center is not required. Maybe all the devices that are produced by the company is working really fine, so the helpline number is not used by anyone, correct? So the helpline receives, there are 2 calls on the helpline per minute. It is on an average based on the previous history. uh, we need to find out the probability of no calls. Now, this particular scenario, it's a discrete probability, right? So what we do is we use a formula here again. So the probability of x, again, what is x here? X is the random variable. X is the random variable. If you remember, we had found out, we had used this terminology before as well. So x is equal to small x. The probability that capital X is equal to small x is given by, so this particular formula is a little different from the previous formula. There is no n involved here, okay? So we use this lambda. You remember what lambda is, right? Lambda is the expectation of a success. We are using this expectation of a success. Lambda raised to the power of x, okay, raised to the power of x, multiplied by e to the power of minus lambda, right? Again, this part is, like once we have the lambda value, this part of the uh, of the formula is taken care of. So you don't have to worry about this part of the formula repeatedly. So e power minus lambda divided by x factorial. So this is the formula for our uh, distribution for the Poisson uh, so this is the distribution function for the Poisson distribution. Okay, so if we walk down this lane a little bit, trying to understand what is happening here. So e power minus lambda, it is, once we have the value of lambda, this is fixed, right? So lambda power x is just saying that there are x successes, correct? So there are x successes. So lambda power x is going to scale our probability value to that extent. More the number of success, maybe the more the probability will become, right? Again, it depends on the value of lambda. If the value of lambda is really small, then something else will happen. If the value of lambda is big, something else will happen. Okay, so let's solve an example and try to find out, to try to solve the question that has been given here. All right. Okay. So yeah. Uh, right. So here in the solution of the question, right? So the question was the call center. So the solution to the question, answer to the question above. Okay. Okay. So here x is equal to 0 and the lambda is equal to 2, right? Lambda is equal to 2. The call center receives 2 calls per minute. So the probability of capital X equals 0 will be equal to lambda to the power x e to the power of minus lambda divided by x factorial, right? And now we'll substitute the values over here, right? We'll substitute the values over here. So lambda is equal to 2 to the power 0, e to the power of negative 2 divided by 0 factorial. Okay, so if you can help me out with this particular calculation, it would be amazing, guys. Hmm. What is e to the power? So 2 to the power 0 is 1. Anything to the power 0 is 1. E to the power of minus 2. Can you help me out with that? E to the power of minus 2. Anyone who is online can help me out. Okay, it's 0.135. 0.1353, 4 decimals. And 0 factorial is 1, right? So please remember that 0 factorial is equal to 1. I will maybe, like create a small box over here and write that down. 0 factorial is 1. 0 factorial is equal to 1. Okay, so this calculation is going to give us 0.1353, and that is the probability, right? So therefore, probability probability of 0 calls is 0.1353. That is the probability. That is the answer. Okay. Now, now what we'll do is let's get into the mean. Let's get into the mean and variance. Now, this is a particular. Uh, so in our case here, the mean and the variance are exactly the same, right? So the mean and the variance are exactly lambda. Both of those are lambda. Again, there is a formula for there is an elaborate um, derivation for this. If you're interested, you can go through some of the previous videos on this channel. But from your exam point of view, I don't think it is required. Okay, so the mean of continued. So if we try to find out the mean of the number of calls, that would be lambda, which is equal to 2. It's given in the question. Variance of the number of calls, which is like okay, so variance is usually mentioned by sigma square, right? So mu is the mean and sigma square is the variance. So sigma square is also equal to lambda, which is equal to 2. Okay, I think I should mention mu and sigma square here as well so that it becomes clear. So mean mu is equal to lambda, variance sigma square is also equal to lambda. Also, in this case as well, uh, I would urge you to go back and like find out the following. Find the probability that the value of x is equal to 5, or uh, the probability that the value of x lies between 0 and 2. Both of them are not included, or maybe one of them is included, right? And so on. Maybe another probability would be the probability of x greater than equal to 3, right? So the first case is pretty simple, right? In the first case, you substitute x is equal to 5. In the second case, you write x equal to 1 and x equals 2, and you add them, right? And the smart way of doing the last one is the method of doing the last one is as follows. We had done that before, right? So probability of x strictly less than 3 plus the probability of x greater than or equal to 3 is equal to 1. So probability of x greater than equal to 3 will be 1 minus probability of x less than 3. And in order to find out probability of x less than 3, you need to substitute x equals 0, x equals 1, x equals 2, right? And then you add them up. So once you find out these three values, you add them and subtract them from 1, you will get the answer. Okay. Now, uh, if you have the calculator, uh, so let's go through this problem once. In this problem, the use of the calculator is pretty important, right? We need to find out, for example, the power of E, right? The power of finding out the power of E is a little tricky task, in the sense that you would be requiring a calculator for doing that. You cannot do it with your hand, right? So you need kind of a scientific calculator, which you will be allowed to use in the exam to do this particular problem. Now, um, Mm, I need to find out where my calculator is. But before that, let's run down the problem that we are solving right now, right? So the distribution. Let's try to understand that. So the Poisson distribution is a distribution where we are having doing an activity while we are conducting trials. The experiment has got trials, but the number of trials is infinite. We are indefinite times we are doing the trial. We are not concerned about how many trials we are doing, right? So for example, an employee of the call center maybe is working in the call center for the last 5 months, and that person will work for the next 2 months, or maybe today is the last day for one of the call center employees. So we are not concerned about how many times a trial is being, how many times we are conducting the trial. Instead, what we are interested in is we are interested in knowing, um, we are interested in trying to understand how many times there is a success, right? And we will be, of course, given the number of, uh, given the mean or the expected value of the success. So you can see that in the red box. Again, there is a success, there is a failure. So this Poisson distribution is an extension of the binomial distribution, in the sense that in the binomial distribution, we know how many times we are doing the trial. We are doing the trial n times, but here we are doing it infinite times. Okay, we are expected, so we are interested here to find out what is the probability of x number of successes. Okay, and the formula is given in the green cloud over there. Uh, Probability of x successes. The capital random variable x is being used to denote the number of successes that we are interested in knowing about. So this formula is given by lambda to the power of x, right? Lambda to the power of x, that denotes the x number of successes, and divided by x factorial. This x factorial is the you know the, so if you look at the if you look at the derivation of this particular formula, the x factorial term is kind of, like, we try to understand the various possible combinations of the x combinations of the successes till now, right? So that's why it's divided by x factorial. Since we are not worried about when the successes are happening, it might happen like in the beginning, it might happen after 5 trials, after 200 trials. We are not worried about that, so just divide by x factorial is fine over there. And we have a scaling factor, e to the power minus lambda, right? So the pretty simple formula. uh, okay, it might be a little tricky to remember that, but still, you just need to substitute one value over here as compared to the binomial distribution. In binomial distribution, you had to put the value of, substitute the value of n, substitute the value of x, substitute the value of p, and also substitute the value of q. Well, q was equal to 1 minus p, and that would have eased the calculation. But in this case, we just need to substitute the value of x once on the power of lambda, and another time x factorial. So the question that we are trying to understand, the problem that we are trying to solve here, is that there is a call center which is 2 calls per minute, and we are inquiring the probability of 0 calls, right? So the expected value lambda is going to be equal to 2, and the value of small x is going to be equal to 0. Now what we do is that we substitute those values, and you can see in the, towards the bottom of the screen, the bottom half of the screen on the right hand side, the second line says 2 to the power of 0, because lambda is 2, x is 0, so lambda power x is 2 power 0. Then e to the power of minus lambda, right? The negative lambda is the power of the exponent. And I think then we divide that by 0 factorial. Okay, 0 factorial is equal to 1. Okay, very important. 1 factorial is 1, and 5 factorial will be 120, but 0 factorial is 1. Okay, so 0 factorial and 1 factorial are same. There are a lot of proofs for this. So if you are not convinced that 0 factorial is equal to 1, you can put them on the internet, to any of the AI bots, or on YouTube. Anywhere you are going to find out the proof of this. It's pretty simple. There are some complicated ones too, but yeah, anyhow, let's not go to that particular value, particular discussion. But 0 factorial is equal to 1, so the denominator becomes 1. 2 power 0 is 1, anything raised to the power of 0 is 1, except 0. 0 power 0 is does not exist, okay, by the way. Okay, so we have got 1 multiplied by e to the power of minus 2. So the value of e to the power minus 2, it might be found out in the following way. So what I'm going to do on the right hand side is try to show you how to do it. On Google, you can find out by just typing e power minus 2, right? And that will give you. And on the calculator, I think you have to write exp or e, and then after that, you have to write minus 2 and calculate it. right? So the EXP button will be there somewhere. It depends from one calculator to another calculator. If you have a specific calculator not being able to figure out, you can come to me and help you out. Okay, so using that calculation, e power of negative 2 is, I got it as 0.1353. I did it on the Google. I just typed it e to the power of e power. Power is like shift 6 on the keyboard, right? On a mobile keyboard, it will be there on the special under the special characters. So that button and then minus 2 immediately after that. So that gave me this value as 0.1353. And yeah, so the probability of zero calls on that particular day on the call center is 0.1353. Okay, so I guess we are done. Oh no, yeah, we have got the mean and the variance, right? So the mean is same as lambda. The variance is also same as lambda. In the previous case, we saw that in case of the binomial distribution, the mean was NP and the variance was NPQ. But you know what? I'm going to add mu and sigma square here as well, just to maintain the uniformity across the document. So mean mu equals this, variance sigma square equals this. So here the mean and the variance were different, but in case of a Poisson distribution, the mean and the variance are exactly the same. And the so they those values are 2 each in this case. Okay. Okay, cool. So I think we are done with the Poisson distribution as well. We solved one problem. We can solve some more problems as well. We'll do that sometime later. Okay, so till now, I would want to hear back from you, your feedback, how you're, like how it is going on for you. Is everything fine? Any kind of, okay, I can see a lot of thumbs ups coming in. Lots of thumbs ups. That's great. Amazing to have you guys here. Okay, pretty simple. Mm-hmm. Anil, thank you. Good job. Naveen, yeah. Okay, Srinidhi, great. Kirti, Supriya, Subodh, great. Okay, okay. Now let's move on to the Poisson distribution. That Poisson distribution is again, no, this is a continuous random variable Poisson distribution.
Hello, sir.
Yes, hi. Someone was, no, not the Poisson distribution, exactly. The exponential distribution, sorry. The exponential distribution. I have a huge problem in this. Exponential distribution, exponential distribution. Okay, the exponential distribution. Okay, one more shot. Let's take it in trying to identify if anyone has a doubt. So, anyone has a doubt? It's pretty straightforward. So, it's good to see that there is no doubt coming from anywhere. Okay. Okay, we are streaming live on YouTube as well. So, that's also there. I somehow could find out that. Okay. So, do you think we should take a short break of 2 minutes? Don't get out of the call. Okay, yeah, let's take a break of 2 minutes and then we'll come back again here. Let me, how do I pause? Okay.